Hi everyone, Mr. Benjamin here, and today we'll be doing rate of reaction, worksheet number 2. So let's read the question together. So over here, 0.5 moles per dm cube, this is concentration of excess. So once we see the word excess, we need to circle them because there's important information. So there's a lot of hydrochloric acid was added to 15 grams of magnesium carbonate. This means that magnesium carbonate is what we call the limiting reactant. That means at the end of the reaction, no more magnesium carbonate and an excess of hydrochloric acid. The magnesium carbonate is also granules, so it's slightly bigger sizes. Alright, so I'm going to produce some gas, and this gas is most likely going to be carbon dioxide because there's magnesium carbonate and acid. So I produce this amount of gas, and then they ask me to write a chemical equation. So magnesium carbonate MgCO3 plus HCl will give me salt, carbon dioxide, and water. So the salt is MgCl2, magnesium chloride, plus carbon dioxide plus water. So now I need to balance this. I put 2 here and it should be balanced. So now I need to describe how the rate of reaction changes with time, and like how the previous worksheet was. You explain why it started fast, you explain why it slows down, and then you explain why it comes to a stop. So first, let's explain why it starts fast. Reaction starts fast as concentration of reactant is high. Okay, so explain why it starts fast. Reaction slows down as concentration of reactant decreases. Eventually, reaction stops as all. So now we need to find out which is the reactant that's going to be used up. So we have a lot of hydrochloric acid, and magnesium carbonate is limiting, means at the end of the reaction, hydrochloric acid is going to be left behind too much, and magnesium carbonate is going to react all finish, as all magnesium carbonate has reacted. So that's my 3 points. Let me remind y'all. Starts fast, concentration is high, slows down because concentration decrease, and then reaction stops because all of the limiting reactant has reacted. So now we need to suggest a reason for the leveled portion. Leveled means horizontal, so it's the same as our third line. So all magnesium carbonate has reacted, reaction stops. Okay, that is why, because one particular reactant has reacted finish. The acid still is behind, but the magnesium carbonate has all reacted finish. Okay, good. So now we need to explain 3 things. First one, 30 grams of carbonate was used. So we started with 15 grams, but now we are going to use 30 grams. So that's twice. So that means instead of producing this amount of gas, I need to produce twice. So the ending point is here, right? We know mass doesn't affect the speed of reaction, so the rate of reaction will be about the same. So you can see the gradient is about the same, and then I'll join these 2 lines together. So the starting effects is representing the rate, and the ending represents the volume of gas produced. So I need to label this graph W. So double the volume of gas, but the rate of reaction remains the same. Next, I've used 0.25 moles of excess hydrochloric acid instead. So I've changed the concentration. I started at 0.5 and now I changed to 0.25. That means concentration decreased. So when concentration decrease means speed of reaction decreases. So the gradient should be lower, right? Because speed of reaction decreases, concentration decrease. However, the acid is still in excess, so the volume produced is still the same. So the volume is the same, gradient is less steep, and then you join them together, it will look something like that, and I label it as X. Okay, last one. So 15 grams of powdered magnesium carbonate is used. So originally it was 15 grams of granules. So we know that granules are bigger, powder is smaller. So powder, the reaction will be faster. So let's look at the green line. If you want to represent faster, means that the gradient needs to be more steep, right? Needs to be more steep. But I still use 15 grams of magnesium carbonate, means the ending point is still the same. So let's look at the green line. It's still the same as the original. We join the starting to the ending, and then we can get to our last graph. It starts very steep and then it tapers to be the same volume. So this is Y. Okay, so let's answer the last question now using collision theory, which is basically the frequency of effective collision, to explain the effect of D part 2. So D part 2 is concentration decrease. So remember, when we are explaining, it's always a 4-step explanation. So let's write 1, 2, 3, 4. Okay, D part 2 is when we decrease concentration. So let's write decrease concentration of acid. Okay, so now we know when we decrease the concentration of acid, let's look at step number 4. Decrease concentration of acid means that the rate of reaction will decrease. Right, so we can write rate of reaction decrease. Now we have written step number 1 and number 4, and then we can write number 3. If rate of reaction decrease means that frequency of effective collision also decreases. Okay, so decreased concentration means rate of reaction decrease. Rate of reaction decrease means frequency of effective collision decrease. And then step number 2, we need to remember concentration relates to the number of reactant particles per unit volume. And in this case, because the reactant is the acid, so it's the number of acid particles per unit volume decreases. So the decrease in concentration of acid leads to the decrease in the number of acid particles per unit volume, which leads to the decrease in the frequency of effective collision, which leads to a decrease in the rate of reaction. So that is how you write your explanation, right, for the effect of a certain variable. Okay, I hope that helps. All right, all the best.